Okay, these notes are over nonlinear systems of equations. These notes have two parts, and I'm only going to go over the first page, which is talking about nonlinear system of equations, and then later I'll have another video going over the second page, which is applications of nonlinear systems of equations. So, solutions to nonlinear systems. When the graphs of the equation in a system are a line linear and a parabola nonlinear, the graphs can intersect in 0, 1, or 2 points. So here we're looking at two types of graphs. We're looking at a quadratic and we're looking at a linear. When neither of the graphs cross, this is called no solution. When the quadratic and linear equation cross at one point, then it has one solution. And when the linear equation and quadratic equation cross at 2 points, then it has two solutions. So it can only have no solution, one solution, or two solutions. Here are the steps for solving a nonlinear system of equations. Step 1 is to solve for y on one of your equations. So step 1, solve for y. Substitute what y equals in for y in the other equation. So substitute what y equals. Solve the equation, which could involve factoring. Substitute the solutions into one of the equations. And then write the solution as coordinate points. So what that means is like x, comma, y. Okay, so let's look at example 1. Our first step is to get y by itself in one of the equations. And if you notice, y is by itself in both equations. So we're going to take this first equation, and instead of writing y, we're going to write negative 2x plus 3. So we have negative 2x plus 3 is equal to x squared plus x minus 1. Okay. Since they're both equal to y, that means each side is equal to each other. So now that we only have this in terms of x and we have an x squared, this tells us that this is going to be something that we need to factor. In order to do that, we need to get one side equal to 0. So I'm going to add 2x over and subtract 3 over. So I have x squared plus 3x minus 4 equals 0. Then I'm going to factor this. So I need two numbers that multiply to negative 4 but add to 3. Those two numbers are going to be 4 and negative 1. So 4 times negative 1 will give me negative 4. 4 minus 1 gives me 3. So I have x plus 4 times x minus 1 equals 0, which means I have x plus 4 equals 0, means x equals negative 4, and x minus 1 equals 0, which means x is equal to 1. Well, since they want us to write this as a point, I have to plug in these x values into either equation up here in order to find y. And I'm just going to try to plug it into the easiest one. So notice how this one looks like the easiest one because it does not have a square. So I'm going to plug in negative 4 in for x and then 1 in for x and solve. Okay, so then I have y is equal to negative 2 times negative 4 plus 3, which is equal to 8 plus 3, which is 11. And then I have y is equal to negative 2 times 1 plus 3, which is negative 2 plus 3, which is 1. Which means I have the answers negative 4, 11, and 1, 1. These are my answers, which means that if I was to graph this system, I would have two solutions. Okay, example 2. Remember, our first step is to solve for y on one of the equations. It doesn't matter which one you pick. You're going to get the same no matter what. So I'm going to pick this second equation here. Okay, and I'm going to get y by itself. So I have negative 3x plus y equals 5. I'm going to add the 3x over, and I get y is equal to 3x plus 5. Now I'm going to take the 3x plus 5 and plug it into the first equation where it has a y. Okay. So when I do that, I have x squared plus 3x plus 5 equals 0, which means I have x squared plus 6x plus 5 equals 0. And then since I have that x squared, I know I'm going to factor. So I need two numbers that multiply to 5 but add to 6. So that'd be 5 times 1 or 5 plus 1. So I have x plus 5 times x plus 1 equals 0, which means I have x plus 5 equals 0. So x is equal to negative 5. And x plus 1 equals 0, which means x is equal to negative 1. Once I solve for these x's, I'm going to plug them into any equation so I can get my y. So I'm first going to plug it into negative 3x plus y equals 5. So I'm going to plug in negative 5 first. So negative 3 times negative 5 plus y equals 5. 15 plus y equals 5. Oops. And then subtract the 15 over and I get y is equal to, so if I subtract 15, negative 10. So that means my first point is negative 5, negative 10. Okay. Then I plug in negative 1. So I have negative 3 times negative 1 plus y equals 5. 3 plus y equals 5. Subtract the 3, y is equal to 2, which means I have the other point, negative 1, comma 2. So again, this has two solutions. So that means if I graph this, it would cross, the linear graph would cross the quadratic graph at 2 points. Number 3 says solve the system of equations. So first we have to get y by itself or see if there is already an equation that has y by itself. Well, since the second equation already has y by itself, I'm going to take whatever it's equal to, so negative 5x plus 9, and I'm going to plug it into the first equation anywhere I see a y. So that would be right here. So that means I have negative x squared minus 5x plus 9 is equal to negative 5x minus 7. Now I have to get one side equal to 0 because I have an x squared. So I'm going to add the 5x over, and then I'm going to add the 7 over. So I have negative x squared. Notice that the negative 5x and the 5x cancel. And then 9 plus 7 is 16. So plus 16 equals 0. Well, I don't want to deal with this negative right here. So I can actually multiply this whole equation by negative 1. So if I multiply the whole thing by negative 1, I get x squared minus 16 equals 0. Now looking at this, you should notice that this looks like a special case of difference of squares. Meaning I could solve this by doing x minus 4, x plus 4 equals 0. Because the square root of 16 is 4. Which means I have x is equal to 4 and x is equal to negative 4. So then I'm going to plug those x values back in to solve for y. So if y is equal to negative 5 times 4 plus 9, this is y is equal to negative 20 plus 9, so y is equal to negative 11. Okay. Which means I have the point 4 comma negative 11. Then I plug in negative 4, so y is equal to negative 5 times negative 4 plus 9, which is 20 plus 9, so y is equal to 29, which means I have the answer negative 4 comma 29. So again, I have two solutions. So if I was to graph this, that means the linear equation would cross the quadratic at 2 points. And then last one, number 4. Number 4, notice how both of these equations already have y by itself, which means I can pick either one to plug into each other. Okay, so let's just say I pick the bottom one. I'm going to take whatever this is equal to and plug it in for their y, which is going to look like the two equations equal to each other. So 2x squared plus 20x plus 44 is equal to negative 3x squared minus 30x minus 76. Okay. Then I have to get this entire side equal to 0 by moving it over to the other side so I can factor. So I'm going to add 3x squared, add 30x, and add 76. Okay. Which means I have 5x squared plus 50x plus 44 and 6 gives me 50. 50 and 70 gives me 120 equals 0. Okay. Now I can factor this, but before I factor it, I'm going to take out a GCF of 5. So if I take out a GCF of 5, I'm left with x squared plus 10x plus I do this on my calculator. 120 divided by 5. Maybe you got it faster than me. 24 equals 0, which means I need two numbers that multiply to 24 but add to 10. Okay, so that would be 4 and 6, because 4 times 6 gives me 24, but 4 plus 6 gives me 10. So that means I have x plus 4 times x plus 6 equals 0. Bring down that 5. And then I set each part equal to 0. Okay, so 5 equals 0. Well, that doesn't make sense, so I skipped that one. X plus 4 equals 0 means that x equals negative 4. And x plus 6 equals 0 means that x is equal to negative 6. Now I plug in those x's to any of the original y equations. So I'm going to go ahead and plug it into that second one where it says y is equal to 2x squared plus 20x plus 44. Okay, so first I'm going to plug in negative 4. So y is equal to 2 times negative 4 squared plus 20 times negative 4 plus 44. So this is equal to, so negative 4 squared is 16. 16 times 2 is 32. Minus 20 times negative 4 is negative 80 plus 44. So I have 32 minus 80 plus 44, which gives me negative 4. So that means I have the point negative 4, negative 4. That's my first answer. Then I'm going to plug in negative 6. So y is equal to 2 times negative 6 squared plus 20 times negative 6 plus 44. Negative 6 squared is 36. 36 times 2 is 72. 20 times negative 6 is going to be negative 120 and then plus the 44. So 72 minus 120 plus 44 gives me negative 4, which means I have the point negative 6, negative 4. Okay, those are my answers. Okay, so again, we're only doing the first part of these notes, and then that's what you're going to do on the practice. And then later I'll do the video over the applications, and then you'll have another practice over that.